I bought myself a new flight controller and I figured I'd do another review of one. This is the CL Racing F4 flight controller. This is the first F4 flight controller that I've bought, and it seems to be quite a popular flight controller. I'll go through the reasons for that in a little bit. Before I start reviewing the board, I figured I'd just show all the other bits it comes with. It comes with 4 of these little I guess rubber standoffs. They've got a metal plug and a metal thread in there, and they're rubberized. So I'm guessing these are supposed to be used for vibration dampening. So they don't come with anything to fix them with, but I'm guessing you can just use the normal nylon plastic standoffs and use these under the board. Give the board a bit of vibration dampening. I probably won't be using these because I've got some little O-rings that I'll use. It also came with this, which is just your normal little servo connector, only it's 2 of them that seem to be joined together. I have absolutely no idea what the intention is for where this is going to be used, because there's no through holes on the board, so there's nowhere where you're going to be soldering pins onto this board. It's always handy to have these though, so thanks for that. And the other things it comes with is some of this 14 gauge wire. This is obviously for your battery connector. It has no battery connector cabled in, so you can use whatever battery plug you normally use, but you have to solder it on yourself. It's got the flexible cover, which is good. It's really nice. I won't be using that either. I'll be using one of these, which you can just buy from Hobby King. So this is 12 gauge wire. It's the same stuff, it's just a little bit thicker, and it already comes pre-cabled, so why not use an XT60? They're like up a couple of bucks from Hobby King for a pack of God knows how many. So yeah, so that's what the board comes with, and we should probably go over the board. Now, like I said, this is an F4 board, and it's the first one I've picked, and I'll go into the reasons shortly for why I don't normally go for F4 processors. I normally prefer the F3 boards, but I thought I'd give this one a go. So this is the top of the board. I guess we'll start off with, you've got your boot switch here, and this has got a built-in PDB as well. So you've got your motor connections. So these are your motor signal ports, and these are for your power connections for your ESC. So these are all in the right corners. There's your M1 down here, 2, 3, and then 4. So this would be the board would face that way on your quad, which gives you your USB connection on the side, which is great. And these 4 connections are all in the right corner. So this is perfect for a quad. Probably not so perfect if you were planning on using it in a wing or something else. But this is definitely designed for a quad. And this thing here, this is a buzzer. This doesn't work on the 1.7 version of 3.7 version of Betaflight, but it will work on the 3.1.7. It will work on the 3.2 version of Betaflight. There are already firmwares for this board that enable that. But they're pre-release versions. So when the full version comes out, that'll be this buzzer will work on the board. And the advantage of that is it's tiny. It takes up no space. It's approximately the same height as the USB connector if you get it on its side. So you get a buzzer on the board for no extra cost. So the other thing on the top of the board is, this has an OSD. So up the top here, you've got your camera connections. So you've got positive and negative power and your camera input. And down the bottom, which side is it? This side, you've got your VTX. So your positive and your negative and your VTX signal. So your camera obviously goes at the front of the quad, which is here. So you'd go from your camera into there, and your VTX can go at the back or maybe sit on top. But your antenna normally comes out the back of the board. So you'd pull those signals out of here, and that would keep your wires fairly small and fairly neat. I'm not a big fan of OSDs, so I probably won't use that. It uses the standard Betaflight OSD, so we've seen that before in other flight controllers. The other things you've got over here is you've got a 5-volt output, and is that ground? What does it say? And you've got your LED, so you can run a LED board off of this one. So you'll notice there's a few things missing on the top here. There's nowhere to plug in your receiver. There's nowhere to plug in your power coming in. And the reason for that is it uses these connections on the bottom of the board for that. So this is your positive and negative battery connections, and this is a current sensor. So it will sense up to 120 amps, which is absolutely excellent. 120 amps. If you can pull more than 120 amps out of a quad battery, you're doing really well. Apparently the board can handle up to 140 or 160 amps. You just won't. You'll max out your current sensor at that point. And your receivers plug into, well, solder onto these connections at the top. So it gets a little bit confusing as to which ones go where. So they're fairly well labelled. This one says S-Bus, satellite, there's a 5-volt connection, a ground, a 3.3 for your Spectrum satellite, there's a PPM connection there, and a telemetry port. And there's a little note on the board here. There's actually 2 versions of this board you can get. This is the newer version. There's a little note silkscreened onto the board to tell you where the satellite goes into UART 6 and the S-Bus goes into UART 1. And the reason for that is S-Bus has an inverted signal. So if you're using S-Bus off of, say, your FreeSky or a Futaba receiver, you have to plug it into that one, and you have to use UART 1 as your connection. And the reason for that is because it's an inverted signal. This has an inverter somewhere on the board, which will flip the signal back round so the board can read it. Now the really, I guess, annoying thing, one of the first annoying things about this board, before I get onto the annoying thing, SD card slot. Full-size slot, really good. So if we get an SD card, you just push it in, oops, there we go, do it properly, it actually clicks in. And to get it out, instead of just doing the normal pulling on it, just press it and it ejects it. So it's a full-sized micro SD slot. It's not like some of the others where it's just a tiny little header that you just push in. And this is the OSD chip. Yeah, so one of the annoying things is it'll take the S-Bus and invert that signal. But with FreeSky, the telemetry is also inverted. And this is the telemetry port, but there's no inverter on that port. So if you want to get FreeSky telemetry off of this board, you either have to invert the signal yourself or you have to hack your receiver. It's fairly simple to do either. I actually have several little inverter boards. They're tiny little boards. And this inverts the signal. It's 3 resistors and a transistor. There's not a lot on this board. They could easily have added this onto the flight controller itself. And the other way to do it is on the actual receiver itself, there's that set up as well. So all you do is you find that setup, and I'll bring this back. In this little setup, say this was on the receiver, you'd pull the signal off of that pin there, and that would be uninverted. So the inverted pin is one of these 2. And that would be the uninverted pin. So you just have to directly solder onto the receiver. I'll probably do a video about that later on because it can be quite complicated. But that's one of the annoying little things on this board. It's not really a big deal. And as they mentioned on their website, most people will probably be using the OSD. And if you're using the OSD, you don't tend to need telemetry on your radio. I like having telemetry on the radio because I like it to buzz and beep when things are going bad. Oh yeah, and the other neat thing is you've got an extra UART port down here, so you've got the UART 4. Yeah, that's basically it for the board. I'm not sure how I feel about having solder points on both sides of the board. This does mean the receiver has to solder to the bottom and the power coming in has to solder to the bottom. It's not a big deal for me because I generally put the receiver underneath the board anyway, so this would actually be the correct size for me. And the power would come in. It doesn't really matter which side the power comes in. I was planning on using this UART for the video UART. So I've done this in a couple of quads now. You can actually, with some of the, with the TBS Tramp or the TBS Unify or the Immersion RC Tramp, you can actually change the channel with your radio. I have a video about that. I'll put a link up here. One of the tricks with that though is you also need you need to connect the video transmitter to the board, but you also need full telemetry to work. So I'm going to be cabling that up with the little inverter that I've got, even if I end up using the OSD, because then it lets me control everything off the radio. So yeah, and then on the top you've got obviously your video connections, which is good, and out to the ESCs, which is great. So not a big fan of having solder points on both sides. It would have been nice to have had them all on the one side, but I can see there's not much space for these. They'd have to have moved some of this stuff around, and I don't know how viable that is. But yeah, so I guess the next thing we need to do is plug it into the computer and just check and see what we've got. Alright, so we're on the computer now. I actually plugged the board in before I started recording just to make sure it was going to work, and one of the really nice things is Windows actually identified it as the CL Racing F4 board. It then set it up as a COM port. As you can see, it set it as COM 8. But yeah, that was a nice little touch. Alright, so if we connect it, we can see it's connected perfectly fine. I actually have the board around the right way as well, which is always nice. And it's responding. So again, this has got a gyro and an accelerometer and nothing else. No data flash because it's got the SD card. So if we go into ports, now there are 4 UARTs, 1, 3, 4 and 6. Because this is an F4 board, you get the extra UART. So I'm going to have to set these up how it tells me. So UART 1 will be the S-Bus. 6 is for the satellite receiver, so I won't be using 6 for anything. 3 will be the telemetry. And 4 are those extra pins at the bottom, so those will be the ones that I was going to connect the video transmitter up to, so that the board can talk to the video transmitter. Now the interesting thing is that you still actually have access to the other port. So if you're running S-Bus off of UART 1, this still exists. There's only one pin for it though, so there's only a receive pin. So I'm not entirely sure what you could use that for, but in theory you could actually use that as something else. It would have to be something that just feeds into the board. I'm not sure what that would be. So if we go down to configuration, so this is how it came configured. Again, set up for 1.25. I'm pretty sure this is the Betaflight defaults. So it's set for 8K gyro and 2K PID loops. The reason it's 8K gyro is because this is on a faster link than the FreeSky one that I reviewed earlier, which is good. That means you can get up to 8K gyro reading. It's got a battery sensor, obviously, because you connect the battery straight to it, and this is the current sensor. Now I'm hoping that this is the correct scale out of the box, and this as well, I'm hoping that's the correct scale out of the box. I don't want to have to go fiddling with it. So I'll give that a test at some point in the future and maybe report back if I remember. And yeah, so telemetry is on by default, black box is on with the SD card and the OSD. That's just pretty much it. You don't really need anything else for that. PID tuning is just going to give us the default PIDs. I don't have a receiver plugged in at the moment or even configured. Modes has got nothing. Motors is not going to show me anything of any use. And yeah, so here's the OSD. So this is just the Betaflight default OSD. As black box, I ejected that SD card, so there's nothing in here, but it will record your flight logs to the SD card and the CLI. So I'm going to do the same thing I did with the last one. and work out the version. So this is Betaflight, obviously 3.1.7. So this is the most current stable version of Betaflight when I recorded this, and the target is the CL Racing F4. Now, if we disconnect and we go into the firmware flasher, when it finishes downloading, so this is the MotoLab board I had previously. So if we go into the so here it is, CL Racing F4. So there is a stable version of Betaflight available for this for download. So the good thing about that is that we don't have to worry about running pre-release versions of Betaflight on the board just to get it to work. It will run out of the box with the most current version. As I said on the bench, the only downside of that is that the buzzer doesn't work in this version. You're going to need to run 3.2 to get the buzzer to work. That's not a big deal for me, and it does mean later on when I update it, the buzzer will start working. But right now it's not going to do anything. And that's pretty much it. There's not a lot else I can really go through on the bench. So if you like this video, give it a thumbs up. If you don't like me doing flight controller reviews, because there's not a huge amount you can review on them on the bench, they really need to be in a quad for you to review them properly. This one will be going in a quad, so I'll do that. If you didn't like that, just give it a thumbs down, and I'll know to stop doing them. If you want to see more of this or other similar things, please subscribe. Thanks very much.